Good day, everyone. So today we are going to be looking at limits, of course, which is a topic we need to know before you even do anything on differentiation and integration. Okay, limits in general simply means a value obtained by substituting and approaching obtaining value of x into a given function. Okay, that's just a brief explanation of limits. So we are going to be looking at it phase by phase. So we are going to start by looking at the first phase of limit, which is the direct substitution aspect. Okay, so we have some samples here which we are going to be looking at. Okay, so we have this, evaluate the following. Let us see how it goes. Let's start from the very first one, which is here. Now, when you are given something like this to do, all you need to do is just for you to substitute the approaching or tending value of x into the given function. Although for some of us who do not understand the meaning of approaching and tending value, let's see. This value of x with this arrow 3, that's the approaching or tending value of x. Okay? And this x squared plus 4x minus 9 is the given function. Okay? So for us to evaluate this, we just have to substitute this 3, which is the approaching value of x, in this function. Okay? So that means this is going to be equals to this x now, you replace it with 3, so you have 3 squared plus 4 multiplied by 3, and then minus 9. Okay? And then this gives us 3 squared, of course, that is 9, plus 4 multiplied by 3 is 12, then minus 9, of course. Plus 9 eliminates negative 9, and then you are left with 12. So 12 becomes the limiting value of this function as x tends to what now? 3. You do the same thing for the remaining samples here. Let's look at the second sample, example 2. So we have lim x to the power 4 plus x to the power 3 minus 3 divided by x squared plus 3. Okay, as x tends to 2. Okay, let's look at this. Evaluating this gives us, of course, I've already told you before now, that all you need to do is just to substitute the approaching value of x in the given function, which means we are going to substitute 2 for x here. Okay, so that gives us 2 raised to the power of 4 plus 2 raised to the power of 3 minus 3 divided by this x, we replace it with 2 raised to the power of 2 plus 3. Okay, and then evaluating further, excuse me, sorry. Alright, sorry for the break. Evaluating further, that gives us 2 to the power 4, of course, means 2 in 4 places by multiplication, that gives us 16. Then plus 2 to the power 3 gives you 8 minus 3. Then divided by 2 squared gives us 4, and then plus 3. And then when you evaluate this properly, see that 6 plus 8, that will give you 24. 24 minus 3, you have 21 divided by 7. And of course, 21 divided by 7 gives us 3. So 3 becomes the limiting value, okay, of the given function as x tends to 2. You do the same thing for sample 3. We have a limit of square root of 4x to the power 2 minus 3 as x tends to negative 2, okay, or minus 2. Substituting directly, this gives us, okay, substituting, this gives us square root of 4, open bracket, you replace this x with negative 2, okay, and then when you do that, you squared, and then minus 3. So this gives us the square root of 4 times minus 2 square. Of course, you know if you square a negative sign, it becomes positive. So when you square 2, that gives us 4 here, and then minus 3. And then this gives us square root of 4 times 4, you have 16, of course, and then minus 3. So at the end of the day, this boils down to 16 minus 3 is 13. So you have the square root of 13 as the limiting value of this function as x tends to negative 2. Okay, so you do the same thing for sample 4, which is right here. Okay, let's see how this will look like. Okay, substitute indirectly as usual. This gives us 1 all over, of course, negative 3 plus 3, which is now equals to 1 all over, of course, minus 3 plus 3, that gives you 0. When you have it in this case, it means limit does not exist, or you just write undefined. Undefined. And the reason being that when you point your calculator, you see that 1 over 0 is going to give you math error or syntax error, okay? So when you have it in this nature, that is in such a way that where you have 0 as the denominator and a non-zero digit as the numerator, okay? Such conclusion becomes what? Undefined, or limit does not exist. I'm going to come back to this in my next video, where I'll be talking about the second phase of limit of a function. Okay, but for the now, when you have something of this nature in limit, it means limit does not exist, or undefined, okay, or indeterminable. Okay, so that's just the first phase of a limit. Please do well to always subscribe to my channel for more videos. Thank you.